Hello everyone and welcome to this tutorial. So today what I want to talk about is the structured clone method, which is a new JavaScript method that allows you to make deep copies of JavaScript data objects. Now you might be wondering why this is necessary, so I created this example to show you what the problem is when you try creating a direct copy of a JavaScript object. So I'm taking the object and storing it, or trying to store it, in a new copy, and I'm changing the first name value of the copy to Jennifer. So what you'd expect to happen intuitively here is for the first name property of the original object to remain David, and for the first name property of the copy to be changed to Jennifer. So let's take a look at the output in the console. So in the original object, the first name is now Jennifer. We expected that to be David, and in the copy the first name is also Jennifer. Now the reason this is happening is that when you try to make a direct copy like I just did here, you are not actually creating a new object but a new reference to the same object. So both object copy and the original object reference, they both point to the original object, and that is why when you change something about the copy it looks like it's changing both objects. Well, it's just changing the original object that both references are pointing to. So this affects JavaScript objects. It also affects arrays. So let me show an example here that is very similar. So I have an original array, I attempt to make a copy of the array, and then I attempt to push the value bond to the copy. Now if we take a look at the output in the console, you see that both the original array and the copy both have bond at the end. So you only want bond at the end of the copy in this instance. So structured clone is a method designed to help you solve this problem by creating a deep copy of JavaScript data objects. So to use it, you just call structured clone and you pass in the value that you want to create a deep copy of. So in this case, the object. And then if we take a look at that in the console, you see now that the first name of the copy has been changed, but the first name property of the original remains the same. And the same solution can be used for arrays. So you use it in exactly the same way. You just call structured clone, passing in the array. That's going to return the copy. So that's going to fix this example as well. Only in the copy is the value bond pushed onto the array. The original remains unchanged. Now, until now, it has been possible to do this natively in JavaScript using a clever hack. So rather than using structured clone, what you can do to get the same result as we just had. So I'll make a copy of making the copy. So the strategy was to stringify whatever data object it was, and then pass it back to a JavaScript object. So it's going from native JavaScript object to string, and then back to an object, and that would be sufficient to create a copy that doesn't point to the same underlying object because it's undergone this stringifying process. Now, if you're familiar with this workaround, you might be wondering why switch to structured clone? Why not just continue using the workaround? So there are basically two big advantages of using the structured clone method over the workaround. The first becomes evident if you add a function into the object as a property. So this will just console log something like hello. So we're still using the stringify method to make a copy of this object. So let's see what the result is. So in the original object, we have our function. In the copy, there's no error, but you can see that there's no function, so it's been silently removed from the object. So you can get caught out with functions not appearing in the copy, and this happens silently, so there's no error message. You wouldn't know it has happened unless you inspect the copy. But if you try this with structured clone, so unfortunately, it's not going to include the function in the copy, but it does at least throw an error letting you know that the function could not be cloned. So with structured clone, you won't lose functions without knowing it. The second advantage of structured clone over the stringify method is that structured clone can properly copy special JavaScript objects like for example date. So if I enter a date here, and I'll delete the function because that's going to throw an error. Now if we take a look at the date property in the copy, so I'll expand the copy. So let's have a closer look at date. You can see it's got a prototype on it with the methods that belong to a date object. So we've successfully copied a date object from the original to the copy. If you try that now using json.stringify, what's going to happen is it's not going to copy the object, it's actually going to stringify that date, so it is no longer an object but just a string. So you now have the date in string format, but you can't manipulate it like you can a date object. If you wanted to use any of those methods that were available, you'd have to feed this string format date back into the date object, which can sometimes be problematic. So you might be wondering about compatibility. So for a while, structuredClone had experimental status, but now it has widespread browser support. You can also use it in Node.js, but it does have only patchy support at the moment in web workers. Now, even though structuredClone has advantages over the stringify method, if your data has functions, you're still going to want to use probably an external library for that. So what I'm going to do is create a function on the object again, and then get the low-cdn. So I have a link here, and I'm going to import that into my project. So I want to show you this just so you know how to copy a function in case the need arises. So I've imported low-now into my project. So I'm going to complete the function here so that it returns something. And then the way that you use low- in your project, once you've imported it, is you start with you guessed it, low-, and then the method you want on this library is called clone deep, and then you just pass the object or array you want to clone deeply into it, and that's going to make a copy also of the function. So if we take a look at the console now, you see that on the copy there is also that function, and if I console log object copy .f, I'm going to run that function, then you see we get this message letting us know it was successful. So if you want to make a deep copy of functions as well, using a third-party library like low- is probably still your best option. But the good news is that for ordinary data objects, if you want to make a deep copy of one natively, you can now do that using structuredClone rather than having to rely on a workaround or a third-party library. So I hope you found this tutorial useful. If you did, please consider hitting the like button down below this video because it helps us with the algorithm and others to find the video. And if you'd like to see more content like this in the future, don't forget you can subscribe to the channel.